Hello dear students. In the earlier class we have discussed about the Jensen alpha, trainer model and Sharpe ratio. All those three models explains the total performance of the portfolio or the fund manager. Whereas here in this Fama decomposition we are going to learn about detailed breakdown of the fund's performance into sources or the components of the performance. Okay, and here we will divide the total return into different sources of that return, and we try to identify the overall fund selection ability of the stock selection ability of the fund manager or the portfolio manager. Okay, so according to Fama, the total return is classified into two, that is a risk-free return and excess return. Okay, so risk-free return is just a waiting time return, just you are depositing and waiting, and that is at the end of the period you are getting that return, that is called as a risk-free return. Excess return, to generate the excess return, that is over and above the risk-free return, we are taking a risk. Okay, that risk is from two things. One is risk premium, and that is the risk we are taking it from the market, and another one is risk from the stock selection. See, this is a specific risk or a particular stock, the risk associated with a particular stock or a company. Okay, this risk premium further classified into two. Okay, the return for bearing a systematic risk, that is a market risk. Okay, and return for bearing a diversifiable risk. Okay, so the total return can be rewritten as risk premium, okay, plus return for bearing systematic risk plus return for bearing diversifiable risk plus return from stock selection. Okay, so in order to get a total return, or the total return is broken into or decomposed into four components. Okay, hence this total return, that is the return of the portfolio, is put into the equation as RP is the function of RF plus R1, R2 plus R3. Okay, here this return from systematic risk, that is what we discussed in the previous slide, that is a R1, can be measured as beta of the portfolio into excess return from the market, that is a RM minus RF. Okay, I hope you all know how to calculate the beta of the portfolio, because this already we have discussed in the class. Okay, so return from the diversifiable risk, that is what standard deviation of the portfolio divided by the standard deviation of the market minus beta of the portfolio into RM minus RF, that is a return from the market minus risk-free rate of return. Okay, so the last component of the equation 1, that is net selectivity, that you can calculate. You cannot directly calculate that one, that you have to calculate after calculating the return of the portfolio. Okay, so and I have transferred except all these R3, rest of the components, that is RF, R1, R2 and all, to the left hand side of the equation, from the right hand side of the equation to the left hand side of the equation. Okay, so RP is the function of R3 is the function of RP minus RF plus beta into RM minus RF plus standard deviation of the portfolio divided by standard deviation of the market minus beta of the portfolio into RM minus RF. So when I work out this one, I could strike out this beta into RM minus RF, and here also one more beta into minus RM minus RF we will get it, beta into RM minus RF we will get it. So these two components are removed, okay, automatically deleted. Okay, so the final equation for net selectivity, you will get R3 is the function of RP minus RF plus standard deviation of the portfolio divided by standard deviation of the market into RM minus RF. Okay, this R3, that is a net selectivity, tells us additional return obtained by the portfolio manager for his superior stock selection ability. It is a return earned over and above the return mandated by the total risk of the portfolio as measured by the standard deviation. Okay, mathematically this is calculated as we discussed in the slides. Okay, thank you. This is what we call it as a Fama decomposition model.